Hello and welcome to this episode of Math with Martinez. In today's video, what we are looking at is simplifying our radical expressions. We're specifically going to be focusing on just the simplifying, but then also adding and subtracting. In our next video, we will look at multiplying and dividing. But let's go ahead and begin by discussing what are these radicals that are going to be discussed. Well, the very first one are going to be those that are the square roots. And so, ladies and gentlemen, it's really important that we know all of our perfect squares. Perfect squares are numbers, like this first one, that when you square it, give us that result. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on and so forth. And so I've listed out here the first 12 perfect squares. Below that in yellow, we have our perfect cubes. They are the values, like 1, when it's cubed, is 1. When you take 2 and cube it, that is 8. 3 to the power of 3 is 27. 4 to the power of 3 is 64. 5 to the power of 3 is 125. And so on and so forth for all of these. Last of all, we have our perfect fourths, and that is the result of taking a value and raising it to the fourth power. 1 to the fourth power is 1. 2 to the fourth power is 16. 3 to the fourth power is 81, and so on and so forth. Ladies and gentlemen, now let's go ahead and look at simplifying our radicals, keeping these very special values in mind. I want to go ahead and highlight here. We're going to be doing the odds. Let's go ahead and highlight what kind of root we are taking. This first one, number 1, is a square root. It is a square root. We know this because there is not a number in this little location right here, right? There's nothing on top of the little foot right there. It is an understood 2. So we are taking a square root. For example, number 2, that is a cube root that we're looking at because right there on top of the little foot of our radical is a 3. And then we have a fourth root. For number 4, again, look really carefully here. Look real carefully. What number is right there on top of the foot of your root? There is a no number, so it is an understood square root. Again, we have a cube root and a cube root. So let's go ahead and begin to simplify these. Here is our process for simplifying our radicals. In problem number 1, what you're going to want to do is you're going to want to find 2 numbers that multiply to give you 252. And you want that first number to be a perfect square. So you want 2 numbers that when multiplied together give you 252, and you want that first number to be a perfect square. So what will work here, ladies and gentlemen? Which one of these perfect squares is the very largest perfect square that can divide evenly into 252? Which of these perfect squares can divide evenly into 252? Well, we know it has to be, of course, less than 252. Go ahead and check and see which one of those is the very largest that divides in evenly. All right. Well, ladies and gentlemen, the very largest one is 36. So here's how we're going to write this. We're going to break this into parts. We're going to be taking the square root of 36, and the result of dividing that is 7. So using our properties of radicals, you can actually take the square root of each of those instead of taking the square root of them jointly. What I mean is, let me back up just a moment here. Instead of saying the square root of 250, the square root of 36 times 7, which is 252, we can go ahead and take the square root of 36 times the square root of 7. And ladies and gentlemen, what does that simplify to? Well, look at here. We have a perfect square, right? We've got a perfect square right here in 36. The square root of 36 is 6. Can we take the square root of 7? Is that a perfect square? No, it is not. So we will continue to just leave that inside the radical. And ladies and gentlemen, this would be our final simplified response. Let's take a look at another. Let's cruise on over here to example number 3. We are looking at taking the fourth root of this. And so again, you're thinking, what two values can multiply to give me 48? And I want one of them to be a perfect fourth. So think of your fourths up here. Which of these perfect fourths is the very largest one that can divide evenly into 48? What is that going to be? Well, ladies and gentlemen, it is 16. So let's go ahead and rewrite this. It would be 2 times the fourth root of 16, and that's times a 3. So we're really saying 2 times the fourth root of 16 times the fourth root of 3. That can simplify a little bit further because, as we have listed, this fourth root of 16 is a 2. So I've got my 2, this one that was out front, now being multiplied with 2, and that is also being multiplied with the fourth root of 3. That simplifies the 2 times the 2 to a 4 times the fourth root of 3. And that is our simplified radical response. One more here. Let's do number 5. We are looking at taking the cube root with that little 3 on the foot of the radical. And in this example, now we have some variables in there. So let's go ahead and take a moment to break this into little pieces. All right. We're trying to figure out what is going to be the factors so that when you multiply them together, right? So that when you multiply them together, it gives you a negative 162. What two factors multiply to give you 162, but you want one of them to be a perfect cube? Just like we saw on the previous one, right? Here, we wanted one of them to be a perfect fourth, and we wanted one of them to be a perfect square in problem 1. We want something that will be a perfect cube and divide into 162. What is the largest value that is a perfect cube and can divide into 162? All right, that is going to be a 27, and it would be a 27 that is negative. 27, which is negative, and then that multiplies with a 6. Okay, so that's the number portion. Now let's think about the variables as well. Let's think about our variables. Do you all recall here that when you're working with your radicals, that you're trying to think here. Let me show you real quick. You're saying, let me do this actually in the little margin over here. When we take m to the 6th power, this is really the same thing as saying what to the power of 3. What to the power of 3? That would be m squared. M squared, and then to the power of 3 is m sixth. And m to the 9th power is the same thing as saying what? M to the what power? Well, how can we do this? What is that going to be? Well, take that and what would we have? Go ahead and divide it, right? Here we took and divided it, and so that would be 3. So that applies here to these that we are simplifying in problem number 5. When you are taking the cube root of m to the 6th, that's going to simplify really nicely to just m squared. And when you're taking the cube root of n to the 9th, that's really just n to the 3rd. So let's break this down. What are we taking here? We're taking the cube root of a negative 27 m, that is squared and then raised to the 3rd power, and your n, which is cubed and raised to the 3rd power, and all that is being multiplied with the cube root of 6. And ladies and gentlemen, check this out. What happens when you take the cube root of a negative 27? The cube root of a negative 27 is a negative 3. The cube root of m squared cubed is just going to be that m squared. And the cube root of n cubed is just going to be your n cubed. And all of that is still multiplying with the cube root of 6. So there you have it, ladies and gentlemen. That is simplifying radicals. Now, what about adding and subtracting? How do we add and subtract our radicals? Well, like I have underlined here, to add and subtract, all you're going to want to do is first simplify the radicals and then combine any like terms. So think about this one. Again, we have square roots, so let's go ahead and highlight those in our purple color here. We're dealing with some square roots, and so we try to simplify. Let's look at this first one. How could I rewrite that? I could rewrite that as negative 5 times what? What can I break 32 into so that like we saw up here, we have a perfect square times another number giving us 32. What is the largest perfect square that goes into 32? Yep, it is 16. You might have first said 4, but 4 is not the largest. All right, now what about with 18? What is the largest perfect square that can divide into 18? It is 9. All right, so let's go ahead and simplify this. This is really us saying negative 5 times the square root of 16 times the square root of 2 plus 7 times the square root of 9 times the square root of 2. Our square root of 16 is actually 4, and that multiplies with the square root of 2. And our square root of 9 is actually 3, and that multiplies with 2. So what do we have here? We have a negative 20 square roots of 2 plus 21 square roots of 2. And when you take a negative 20 of an object and add 21, that gives us just 1. You're saying negative 20 plus a 21, that gives you just 1 square root of 2. You do not have to put that 1 in front. You can actually just write square root of 2 as your final answer. All right, just about done here. Let's look at example number 9. Again, we need to simplify. So let's think to ourselves, negative 3 times the cube root, because we're dealing with cubes now. Let's go ahead and highlight that in yellow, and you're going to want to look up to those yellow perfect cubes. So when we are working here, what is going to be a value, a number, one of our perfect cubes that can divide into 56. What is the largest of these perfect cubes in yellow that can divide into 56? It is 8, and I'm going to recommend that we keep that negative. Negative 8 times a 7. And then we're going to add to that the cube root of what is the largest perfect cube that can divide into 189? That is going to be 27. 27 times a 7. So let's go ahead and simplify. We're really taking the cube root of a negative 8 times the cube root of a 7, and adding to that the cube root of 27 times the cube root of 7. Simplifying, we have negative 3 is being multiplied with the cube root of a negative 8 is actually a negative 2. And then that's multiplying with a 7, cube root of 7. The cube root of 27 is 3. And that's times the cube root of 7. Negative 3 times the negative 2 gives us 6. Cube root of 7 plus 3 cube root of 7. So ladies and gentlemen, how many cube roots of 7 do we have? 6 plus 3, that gives us 9. And there you have it. That is adding and subtracting our radicals. It is really just first simplifying like we did in these, and then combining our like terms. If you all had any questions from this video, please take a moment to share those now. And until next time, stay fired up.